Hey everyone, good morning and good evening. Let's start with today's session and let's see what exactly we are doing today. So, yesterday we spoke about service connection. We created basically service connection also. So, let's go and look into it first. So, this was the account which we have used. Sign out. Sign back in. devopsmela.com. Okay, while this is coming up, the focus area of today is we'll have to deploy what we have created last time. So we have a .NET application which we built last time. Now we need to focus on deploying that application. That is the whole purpose why we have created a service connection, so that we can connect to a Azure cloud services. Yeah, this is up now. Let's go and verify if we have the service connection. Perfect. So we do have a service connection. Now I can connect to my cloud services perfectly. Now before I jump on, we need to understand two fundamentals. What is continuous delivery and what is continuous deployment? We do have a build. Let's verify. Yes, we do have a build. We have an artifact created. Let's verify. Yeah, we do have a zip file. This needs to be deployed. Now again, using a classic method, I'll help you with deployment, but we need to understand two fundamentals before we jump on. What exactly is deployment and what exactly is delivery? So anyone wants to pitch in? What is deployment and what is delivery? What is the difference between them? Anyone wants to try?
I think delivery has to do with where manual input is involved, whereby probably you need to click on a button for your release. Why the continuous deployment has to do with a full automation, whereby it triggers a build and it continues in that cycle.
Perfect. Anyone wants to add something? No one?
Yeah, apart from I think Babatunde just said exactly what happens, but I just wanted to add that for continuous delivery, most of the time you need approvers, and then for continuous deployment, you usually set it on you enable the trigger which does not require any approval.
Perfect. Great. So yes, bang on guys, thank you very much. Let's go and see in details what exactly this means. And these are definite questions in interview. So continuous deployment and delivery. So first we talk about delivery. We have seen the build process. Build process is nothing but your continuous integration process, correct? That is your build process, wherein your application is getting built, the application is getting tested, the application, if there's any and the artifact is getting created. You have an artifact in place now. That is your build process. What happens after build? After build, there are lower environment and upper environment. I'm talking about a real-time scenario, guys. I'm taking an example of 4 environments: dev, QA, stage, prod. Dev QA will be a lower environment, stage prod will be a upper environment. Okay, so in continuous delivery, once the build is successful, the things will be deployed into dev automatically and the QA environment. Post which the changes will be pushed into stage. But in order to put things into stage, this is not a direct deployment. This will be having some pre-approval over here. So you will have like what kind of approvals could be. So in QA, what we do all sort of QA testing, all manual, automated, integration, and all sort of testing is happen in real time happens in QA. Now the QA team will give you a go ahead that the code is looking good. This can be deployed further. Now after this go ahead, someone maybe from your lead or maybe the application owner will go and approve the stage deployment. Then only it will go in stage. Once it is approved, there could be some sort of post approval also, like if you want to have some dynamic testing, you want to after the deployment you want to see if the integration is working or not. There are n number of checks which they do. So once the stage is deployed, and if you want a post approval also after the deployment, we have an option in continuous delivery. Post which you will have production, and production has the same pre and post funda. When in production you will have same sort of pre and post fundamentals. Now this is your lower and this is your upper. So continuous deployment is an automated release process. We can deploy our application at any time by clicking a button. So by a button click, you have the pipelines and everything in place. So by a button click you can deploy things in continuous delivery method. With continuous delivery you can decide to release daily, weekly, fortnightly, or whatever suits your business requirement. So mostly 70% of time they follow continuous delivery model, wherein they have bi-weekly release, quarterly release, fortnight release, monthly release, 3 months release. So they tend to follow continuous deployment, continuous delivery method. And plus, why exactly they do follow continuous delivery? Because of monolithic applications. Why monolithic? Because doing the monolithic application, when they make any changes, they want all the team to be part of that call, because no one knows what will be the impact of this new change. That is the biggest disadvantage which you will find in monolithic application. Okay, monolithic, just an FYI guys, it's just nothing but it's the deployment is happening as one single package, wherein all your modules are clubbed together, they are highly coupled together, and they get deployed. Now later when you're making changes to those applications, there is a great chance that the integration which is there with that application may get impacted if you make any change. So hence they follow delivery model, wherein they get into a call, they deploy the changes, then all the application team, they will start checking if their application is working or not. This is what they do even now. Most of the companies, they are stuck with monolithic. Okay, so in monolithic, if you even think of continuous deployment, that is out of question. There are so many things involved in between that you can't even think of continuous deployment over there. So with continuous delivery model, codes gets deployed in lower environment without manual intervention, but for the upper environment deployment, manual approval is the must. Okay, the manual approval is not just the person who wants to feel important. No, it's not that, guys. So manual approval has multiple reasons. They want to check if the pre-prod environment was deployed successfully. They want to have the QA report. They want to have the load reports. They want to check the integration testing, how it went. Everything they need to check before they go and deploy things in production. And even in production, even though after all these checks, even in production, it's the complete team from all the application team is sitting together and they are deploying it over a call, so that immediately once the changes are deployed, they can go and test it, and if there's any issues, they can go and revert the change back. So this is the whole purpose why they follow continuous delivery model. Continuous delivery in real sense, it is not following DevOps culture. DevOps is all about when you test your application, when you build your application, you're good to go. Once your artifact is built, you are good to go. Your application should not break. That is what that is what DevOps culture talks about. But we have restrictions. As I said, monolithic has n number of restrictions. The database is not in sync, the application is not in sync, there are n number of loopholes, there are tightly coupled modules, the application codes are not backward compatible nor forward compatible. So in such cases, in such issues, this is very normal and very day-to-day out issues which I'm talking about, guys. When you start working as a DevOps engineer, when you start setting up all this, you'll come to know what exactly these issues are. Because of this, you cannot go with continuous deployment model. So this is continuous delivery, wherein even though everything is automated, you still wait for a person approval. This is not, the person is not your manager or some who doesn't have any technical knowledge, nothing as such, guys. This is, there are n number of teams involved in the backdrop who are continuously working and checking that if the whatever new changes are deploying does not have major impact. Okay, that is where delay. And plus, if you have any cycle, deployment release cycle, wherein you are doing a quarterly release, monthly release, then you guys are following continuous delivery model. Okay, but in real sense, if you ask me what is DevOps and what is the model we follow, then this is what we follow: continuous deployment. As I said, if the package is built, if you have an artifact created, so that means the packages can be deployed to all your servers. There's no stopping in between. The package will be deployed in all your servers till production. No approval, nothing, there's no stopping. Okay, so continuous deployment goes one step further than continuous delivery. With continuous deployment, every changes that passes all stages gets deployed till the production environment without human intervention. There is no human intervention, guys. Very important point, no human intervention. If it is successful in dev, it will go to QA. If QA successful, stage successful prod immediately. No release cycle, no quarterly release, no monthly release, no approval, nothing. It will go till production. So if you want to follow continuous deployment, your application should be very robust. Your build integration pipeline should be very robust. Okay, and this is what it should be. Your build should be very robust. You should have all sort of static testing, you should have all sort of code coverage, you should have your unit testing, making sure all your application code is line by line is tested, and then the package which gets created, you should have a better understanding of deploying it. Then there's no problem, you can deploy till production. Who can achieve this? Who can achieve this? This can be achieved when you have all DevOps culture followed. And if you are not using a monolithic, to be very specific, you are using a microservice application. What is the difference between monolithic and microservice application? Microservice application, just think of a car. In a car you get so many other, you have the machine, you have there's driver's seat, you have the steering, you have the tires and all this. So in monolithic, what we are doing while building the car, everything is getting built all together at the same time. In microservice, we build the tire first, we build the machines later, we build the steering, we build the seating, we build the interior, and all this we are doing separately. So if there's any issue with the tire, we go and replace the tire, just focus on tire, then we replace it and we create a new tire. it is not impacting the other components of your car. And later when everything is built, we are loosely coupled, not highly tightly coupled, we are loosely coupled. Using APIs and REST APIs, we are loosely coupled so that they can communicate, those components can communicate with each other. What is the beauty of doing such way? Any of your component is affected, or if any of your component is getting upgraded, like you're upgrading your machine, the car engine, okay, the horsepower you're upgrading to 1000 horsepower, that's a supercar which you're making, okay, so you're just working on that part. That is the same way you can replicate the same idea in application. Just think of the shopping website which we were making down the line. We had the different module, as I said, finance module, shopping page module, all these modules you will have your payment gateway module. All these modules you will be building it separately. All these modules will be deployed separately on either a VM or a container or a Kubernetes, wherever you want to deploy it. If any of this module has some issues, or if you want to upgrade, you will just pick that module and you'll start working on that module and you'll deploy that module without impacting other modules. And how this modules will communicate together using REST APIs and all, and there are loosely coupled. Tightly coupled means it's very difficult to make it separate. Loosely coupled, easily it's one module is running in one pod, the other module is running in another pod, and it's all loosely coupled. Okay, so that is the major change at the infra level, at the coding level, which needs to be done if you want to follow continuous deployment model. There are other strategies in the world. There are different sort of strategies which you will come across for your deployment. Many of you have heard blue-green strategy. There are rolling update strategy. There are canary strategy. There are a number of isolation strategy. There are mice and cat strategy. There are so many strategies in the world. But this all strategy, like take an example of rolling update, this all strategy works if you have microservice application. If you are having a monolithic application, let me tell you, none of this strategy will work. You have to stick with straightforward, simple deployment strategy when you have monolithic. Now if you want to have monolithic to be converted into microservice, so there's a great change in coding required, guys. It's not that tomorrow you want to convert a monolithic application into microservice, you decided and did it. No, it's not that easy. There are so much of integration. The code rewriting needs to be, you have to rewrite the code as per microservice. The modules needs to be divided. You need to have loosely coupled. You need to, the first step you need to do, decouple the modules. All this comes with a cost. Hence, whatever company you see, they are still following monolithic. The reason is straightforward. That's their bread and butter. The production is working because of that application, and they are scared to touch those applications because they think they may end up making it down, and they may end up creating more issues for them. So that's the reason they don't touch it. They are still keeping it monolithic, and no one is aware what's happening. And they have a straightforward continuous delivery model what they follow, and they're doing the deployment and they're happy. Though disadvantages, you cannot have zero downtime. If you want to deploy something, you need to take a proper downtime, 5 hours, 6 hour downtime, then you deploy your application, test it, then your production will be up. In continuous deployment, there is zero downtime strategy what we follow. What is zero downtime strategy? Rolling update, canary strategy, rolling. I'll talk about all this strategy later in this course, guys. For now, if you want to achieve zero downtime, what do I mean by zero downtime? That if you're doing deployment in production, there is no downtime. Then we will follow continuous deployment model in such cases. Okay, so this is what continuous deployment model is all about. So with continuous deployment, only a failed test will prevent a new change to be deployed. If there is a test which gets failed over here, that will only stop your continuous deployment chain. Okay, with continuous deployment we can completely bypass release date and accelerate feedback loop with the customer. So there is no requirement of a release date if you have a continuous deployment model. There is no release date, guys, basically. Okay, you will have a direct deployment done without human interference. This is a major difference between continuous deployment and continuous delivery. Okay, makes sense? Anyone has any questions? Anyone? Any questions, guys? No questions? So let's go and see the continuous delivery first, then later I'll show you how do we enable continuous deployment also. Let's go and see continuous delivery. Okay, so we already have an application which we have used it. Which we have built it. Now this application needs to be deployed. Now I want to deploy this application on Azure Web App. As of now we haven't written anything in Terraform nor in ARM, so I don't have a template to create the web app. So what I can do, I can create it manually. Okay, Azure Services. App Services. So basically what exactly it is, this app services are basically, you can create web app in this. Those are managed service by Microsoft. What do I mean by managed service? So for deploying a .NET application, what all things you need? Minimum, you will need a web server, you need a VM, you need that web server to be configured, and all this thing you need to do it manually. You need to have a .NET deployed on it, and you will have a VS build also. So all these things are required. You need to set up this by yourself if you want to deploy a .NET application. Now I don't have time to do all this. What I can do, I can make use of app services. App services are basically, if you see closely, it's a VM which gets allocated to you, but you will not have access to those VMs. The max you can do, you can log in and can check the logs. That is the max you can do. But this will have the complete package. So whatever the prerequisite is there, it will have all the prerequisite installed. The only thing you have to do is get your application package and deploy it on top of it. So nowadays this app service is getting used at a very faster rate. I see companies are utilizing this app service method wherein they don't have to manage the underlying VM. With VM, like virtual machine, you have to even manage the VM, the patching and update, all this you need to take care by yourself. With app service, this is all Microsoft headache, not yours. The only thing you worry about, your app service is working, you deploy your application. If you want to auto scale, you want to upgrade, this can be done very easily. Okay, so let's go and create our first app service. Again, let's create a name of your app service, give whatever name you want. I just name it as devopsmela. So it's a code, Docker container. What's your publish method? Or it's a static web app. What are the public method you want? So do we have a Docker container image? No. So it's a code, definitely a code, correct? I can go and select the run stack. This is ASP.NET, correct? It supports ASP.NET, it supports Go, it supports Node, PHP, Python, Ruby, Java, everything. Even it's Java, it's supported. So ASP.NET, let's select 3.5. Okay, that is 3.1 we have, which we have, so it should work on 3.5. Region East US is okay. Windows plan, this is where the billing happens, guys. This is the plan which getting created. So whenever you create any resources, the first thing is resource group, the second thing is the service plan. We can also call it as service farm. Okay, the third thing is the resource which gets created. Now I have selected the plan. This is the plan. Let me see if I have something very least which I can select. I can even go with this, guys, F1, shared infrastructure. I'll talk about this F1 and all later. For now, this comes in free tier, so always stick with F1 for now. Deployment, there's no deployment for now. Networking, public access on. Monitoring, and no monitoring needed right now. I'll click no. I'm just interested in creating this web app. Okay, so we'll have a web app created. So under app services, the things what you create is known as web app. So there's a great confusion. What is the difference between app service and web app? So app service is nothing but under the app service you create web apps, guys. Okay, so under app service you can create multiple web apps basically. So you will have your web app created. Now on this web app I'll have my pipelines created through which I'll be deploying my application on this web app. Okay, now in order to create the pipeline we can go to releases. This is the, and this is again we are using classic method to deploy. I'll keep it empty for now. As soon as you click on new release, and I'll name this as dev for now. Let's name this as web app dev, something like this, release, whatever name you want to give it. Now there's an artifact. Okay, we already have a build pipeline, so we'll go and select add an artifact. There are multiple sources through which you can add an artifact. One is through the build pipeline. If you have a build pipeline directly, if you want to put it from a repository, even that is possible. So in my case I have a build pipeline which I'll go and select. So this is my build pipeline. Default version latest, so whatever latest push we have, that will be taken, and I'll just add it. All this integration I'm not enabling right now, so I'll just keep it everything manual. We'll talk about this in a greater details later. For now I'm just keeping it manual. I'm just waiting for my web app to come up. I have the web app. Now this is the URL, guys. If you want to change and if you want to have your own custom URL, then you need to do a domain mapping and DNS entry and everything. You need to create a record and many things you have to do if you want to have your own URL. So if I go and look into this web app, I should get a default page. The web application is running, waiting for your content. So you have everything in place. So your platter is ready. You just have to go and pick your boards. This is what web app is all about. Wherein if you are creating a VM and if you're setting up all this by yourself, you need to do everything manually by yourself and manage things by yourself. Keep that in mind. Same in AWS, this is Elastic Beanstalk, the one which we have app service over here. In AWS if you go, it is Elastic Beanstalk. Same thing, it's the same thing, same fundamentals. Okay, now I got the web app. Now I'm creating a release pipeline. So this is the artifact I have added. This is my source, what I have added. Now if I go inside this task, I don't have any task running in right now. But if you see the agent pool, automatically it selected the agent pool Windows 2019 and or with Visual Studio on 2019. So what is agent pool? We all know. So there will be a deployment task which I will be adding. That deployment task will eventually will be running on this particular machine. Okay, later I'll talk more about this agent pool. For now, just keep this in mind. So let's add a task. What exactly we are doing? Deploying ASP.NET application on Azure App Services. So I just put Azure App. I should see something like this. So there are multiple options. Container app, no. Do you want to start stop services? No. Deploy Azure App Service Web Mobile API using Docker, Java, .NET, .NET Core. Perfect. This is what we are looking for, correct? If you want to know more about this, this is by Microsoft Corporation. You want to learn more about this, this will take you to the GitHub. Now this, if you read through it, this task works for ASP.NET, ASP.NET, PHP, Java, Python, Go, Node.js web application. So this is what we are looking for, correct guys? Now what all types of packages it supports? It supports var, jar, it also supports zip file, zip deploy. We have a zip file, correct? So this is more relevant task which we can select. There is one more over here at the bottom. Azure Web App. Deploy Azure Web App for Linux or Windows. If you go and read through it, it will not have the zip support. So you need to identify which is the task you need to select. So select this task. Now it is asking for subscription. This is where you will need your service connection. Your service connection will work over here. App service type, web app on Windows. Yeah, if you remember this web app which we have created, this has Windows on it. So web app on Windows. App service name, devopsmela. This is the name. How I am getting this name? All thanks to service connection. That's why I'm getting this name in my drop down. If I don't have my service connection, your name will not be visible. Package folder, it is looking for a zip file. Now hopefully we know this, guys. So the drop location what we have created during the build, the drop location which we have created during the build, it is nothing but system default working directory. Again a predefined variable. A local path on the agent where your source code files are downloaded. Remember, we were publishing the artifacts to a drop location, and this is the place where the drop location gets created. The source code files are downloaded. See the logs and see the published task. From this artifact location, it is getting downloaded at this location, and if you want to access this location through your pipeline, release pipeline, then you need to make use of system default working directory. That is what I am doing over here. System default working directory, calling it $ open bracket close bracket system default working directory, and I don't know where exactly the zip file is, under which folder, so I'm making use of ******.zip. This is what we call it as relative path. If you want to have absolute, you can go inside your build, select the drop, have your zip file selected. This is called absolute path. Absolute path you should not select, because what will happen if tomorrow if you want to create a new pipeline using the same task, you'll have to make changes. You have to go inside and make changes. So as of now, let's keep it absolute. Later I'll show you how to make existing how to create new pipelines using existing pipeline. For now I'm keeping it very simple. Let's use absolute. That's it. This is the only task which I need. Nothing else I need. Okay, I have the task ready, I have my zip file ready, everything is ready. Let's save it. Okay, now if I go to my releases, I have my web app dev release. Now it's not been released yet. What I can do, I can click on, manually I'm doing all this. Later we can have, when we are following continuous deployment model, we can have everything done automatically. For now I'm doing it all manual. Okay, this is, if you want to verify your version is, this is the version ID. This is the latest version. If you want to select the previous one, even that is possible. You can go and select the previous one also. For now let's stick with latest. Release 1 got created. Because this is all manual, guys, I'll have to go and deploy things manually. Now this is a first simple continuous delivery model what we are following, wherein we are doing everything manually, clicking on the deploy button and doing things manually. There are many things in your pipelines like predefined variables, post-defined variables, variable grouping, integrating keywords. There are many things which we'll come across later in this course, but for now this is a simple release pipeline wherein we are trying to deploy a .NET application. Got service connection. See this, it is the first thing it does, it's getting the service connection, and then it is getting your zip file from where it is getting artifact location, and it started extracting your zip file. Initialization job, the first task, it is creating a host agent. See, a Windows 2019 server is getting created and that has been assigned. You are getting logged in as a VS administrator. Then once all the other required things are getting installed on top of it, once this is done, your artifacts are getting downloaded. So basically it is downloading your artifacts. See, all your zip files and everything is getting downloaded from your artifact location. Once it is done, it is running your build, not your build, it is running your deployment. Okay, let's wait while this is still running. If you want to see the logs, go inside agent jobs and you can see the log. Now this is completely done. It has been all extracted. If I come down, app service URL, your successful history logs, everything will be visible over here. How do you go and access our application? There is the page. Copy this URL. You should see your own application. Welcome to devopsmela testing CI. This is something latest we have updated, correct? This is something we have got on my local system. Now this is got deployed on Azure web app. One-click deployment. Make sense? Anyone? Any questions? This is all we did manual. Later we'll have this web app which we are creating manually. We'll have a ARM template, and by just one click we'll have a new environment created, and we can have deployment done on the new environment by just one click. So all this will automate later, but for now this is a simple straightforward build and release what we did it in Azure. Okay, anyone, any questions guys? No questions? Okay. Now if you want to create a new environment, suppose, okay, when you click on edit, there are two types of edit you come across. Edit release. Edit release is basically just editing your release 1, not your actual pipeline. Keep this in mind. I have seen many people making mistakes over here. What they do, like suppose if they want to make any changes to their actual pipeline, they do just come over here, edit release, and they just update the release 1. The actual pipeline is not updated, and they create a new release and they run it, and they end up getting the same error. They come to me asking, I have done the changes but still not reflecting. The reason is they are editing this release 1 right now. If you want to edit your actual pipeline, you have to go inside edit pipeline. Now this will take you to the actual pipeline wherein you can go and make changes. Okay, so keep this in mind, what exactly you're editing, whether you're editing a release or whether you're editing your actual pipeline. Okay, now this is all manual I did. So if tomorrow if I make a changes to my local, if I push things directly, my release will not even get created, because we have not enabled the continuous deployment trigger. Now if you want to, this was continuous delivery kind of, not even continuous delivery I would say, but if you have a continuous deployment trigger, this is what you can do. You can enable this, continuous trigger. What will happen? Whenever there is a build, a new build will be created. You will see a new release also getting created with this trigger. This trigger which you have. There are other filters which you can put in place. Branch filter, pull request filter. If you want anything as such, then you can have such conditions added. But in real time, this is your continuous deployment trigger. Okay. Now what will happen with this trigger? When there's a new build, a new release will be created. So you will see whenever there's a new build, you'll see a release 2 getting created. But that release 2 will not get deployed automatically. The reason is you will have this pre-deployment condition in place. If you want this deployment to happen automatically, then you need to go here, select a trigger that after release. What do I mean by after release? Whenever there is a new release getting created, this dev deployment should happen automatically. If you want this, then you need to have after release selected over here. Now this is in a real manner, if you ask me, it's a continuous deployment what you are doing. So whenever there is a build successful, automatically your release will be created, automatically your release changes will be deployed into dev environment. Similar to this, there are other conditions which you can select. Artifact filter. If you want to have a schedule done, like even though if the release gets created, even though the things are starting getting deployed, you want to schedule it like after your business hours only you want to deploy things. If you have any such conditions, then you can put schedule over here, that after business hours only the changes should get deployed. If you have any such conditions, then you can even have a schedule done over here. If you want to have a pull request requirement deployment, there's one more condition which you can set. If you want approvals, this is a place wherein you will go and add approvals, guys. You can have approvals. So without this person approval, you cannot have the things deployed. And there are other condition, approval policies condition which you can put in place. Gates. Now this is very important. Gates. These are known as quality gates. These are basically used if you want to have a time period between two releases. If you want to buy some time out. Now think of, there are two environments, dev and QA. No, the QA is not, dev is not the right. Think of there are two environments, QA and stage. Now your changes got deployed into QA. Now you're following continuous deployment model. Keep that in mind. Your changes has been deployed in QA. Now there is an automated test which needs to run for 60 minutes before the next deployment happens, before it goes to the next stage. Okay, if you have anything as such, because what did I say in continuous deployment model, there's no human interference, there's no human anywhere in between. Now there is an automated test, but and you need to run that automated test first before things goes in the other stage, and you want to buy out a 60 minutes of time in between to run that automated test. So how do you do it in continuous deployment? Then you will have this evaluation gates. So define gates to evaluate before the deployment. Okay, so this will basically not get added over here. This will be most in your post deployment. Once one environment is deployed, then you want to run the automated test, then the next environment should deploy. If you have any such requirements, then you can go and add this gates option over here. See this, I'm just removing it now for now. Then deployment queue settings. If you have multiple agent pools, so we don't have multiple agent pool, this is only agent pool what we have right now. If you have multiple agent pools, then you can go ahead and select this deployment queue settings. Okay, this is your pre-deployment conditions, guys. Similarly, we'll have post-deployment condition, and this is the place wherein you can have gates added. This is the most relevant place wherein you can have evaluation gates added if you want to have a buyout time in between. So if you have any such conditions, if you want to have a buyout time, then this is the place. Even for post deployment approvals, if you want any post deployment approvals to be added, you can add the person name over here. You can add a person name, you can add a group, whatever you want to add it. Auto redeploy trigger, if you're in case of event of failure, if you want to redeploy anything, you can make sure auto redeploy failure is enabled. So if your task has failed and if you want to try to redeploy it, then this is the option which you can come and select. So these are your post and pre-deployment conditions which you can go and add it. At the bottom, if you see clone. Now what did I say over here in the task? No hard coding. If you hard code, what will happen if you're trying to clone? I'll have to go and make changes under also. So this is if you want to create a clone copy, then this is how you create it. I'll talk about this later when we have ARM and all. When we go through ARM, then we come back to this release pipeline. Then I'll talk about variables and everything at that point of time. Okay. So this is your basic release pipeline, your precondition, your post condition. Now if I save it, done. So how do we test this? One way to test, open Visual Studio, make a change. I don't have the clone copy also. Let's go to repo, clone it. Now just imagine I am a developer. I'm cloning my remote repository for making a new development. Done. Let's go into done cd DevOps. This is my application. Now I can open Visual Studio and can make changes to my index file, or else I can just go to pages, open the index file, not this one, open the index file. What exactly we have written? Welcome to devopsmela, testing CI, testing continuous delivery model, continuous deployment model, testing continuous deployment model. Okay, something different. So it's a new version of application. Save it. Now if I go to my Git, if I check the Git status, I should see change. Correct? Now let's do a quick commit. Updated index file. Now this is what a developer will do. The only difference in reality the developer will do is he will create a new branch, a temp branch, then he will go and make changes to the new branch, then he will test the things locally, then he will create a pull request from the temp branch to the develop branch, then the things will happen. So I'm not spending all this time. What I am doing, I am making changes directly to the develop branch, and now I am doing a commit. Now I'll do a push. So what should happen? Eventually the changes got pushed. What should happen? Your build should run. See, the build is running right now, and once the build is successful, your deployment should also run. Let's wait. Your deployment should also, there's no human intervention anywhere. The developer did the development, he did the push, the changes are there in the remote repository. Now we are just awaiting the build to get successful. Once the build is successful, I want a release 2 to get created automatically, and the release should get deployed, and we can verify it by seeing the page where the page is. Okay, let's wait. This is in a real manner. We're talking about continuous integration and continuous deployment. Okay, makes sense? Let's wait. Okay, the build is successful. Now one difference, what you see at the top after the summary, there is a releases tab which is popping up right now. If you click on the releases tab, the release 2 is also created. See, the release 2 got created. Okay, there is a approval pending, guys. We have added an approval. Now see, it is asking for my approval. Okay, so this is how the approval looks like. If I go and approve it, your pipeline should start running it. Okay, we have evaluation of 5 minutes also added. Okay, so everything we have added. I can't wait for 5 minutes. Let me cancel this and let me run it. Okay, so now because I cannot remove the gates and everything, edit release, remove this approval. See, I cannot remove gates any which ways. The gate is added. Now in order to remove the gates, I have to create a new release, guys, or wait for 5 minutes. Any of this I can do. So discard this, go and edit the actual pipeline now. Come over here, remove this, remove the gates, save it, and for now let's manually create this release. Release 3 got created. Now I'll deploy it. See, so because of there are two conditions which we had previously, the gates and the approval, because of which the continuous deployment was not happening. Now we are back to continuous delivery model and we are doing it manually. Okay, now let's see if the deployment is happening or not, and I should see the newer version of my code getting deployed. Okay, let's wait and see. Deployed. How do we verify? I can go and open my application. Open this page. You should see the newer version of it. Let's wait while this is coming up. It's taking good amount of time. Let's open in incognito mode. Guys, try it from your side also, if you are able to see the new change. This is taking time. The deployment was successful, but if you see, there is a processing gates which is happening right now, and there's nothing to do with the application. Your application is deployed, guys. So this is just we have added the gates at the other side also. It's running the processing gates. Your application should come up. Let's have this application up.
Rohit, one question here. The gates which we defined, usually it's a sonar queue quality checking kind of we do it, right? Usually
No, not a sonar
the
queue.
gates is
Not a sonar queue. Sonar queue will happen during your build process only. Sonar queue is more of a static code analysis. And if you define a gates and the type of testing what you do, more are dynamic, more are black box testing, more related to your integration testing. All this testing happens after your deployment. Okay, so SonarQueue is more of a white box testing. You have the source code, everything is there, and it goes and does the quality check and many things. So that will happen during your build process, and your dynamic testing will happen after the code is deployed to your environment. Okay, now if
okay,
you
fine.
see this, welcome to devopsmela testing continuous deployment model. So your new version of application is also been deployed successfully. Are we good till here? Any questions? Now this gate is let the gate remain as it is. Okay, now that's it from this release, classic release, guys. Tomorrow we'll talk about agent pool. So we'll focus on what exactly is agent pool, what is self-hosted agent, what is Microsoft hosted agent. Then Monday onwards we'll start with ARM templates, and once we are done with the ARM templates, we'll come back to this release pipeline again, and the things which we are doing manually, creating the web app, we'll do it through ARM template. We'll see how ARM template can be integrated with your pipelines, and we'll see how a resource will be created through a pipeline. At that time we'll understand more about variables. We'll see what are predefined variables, what are custom variables, what is a variable group, and all. We'll understand that. Okay, so that is the plan for next week, and so I think we'll spend the complete week understanding all this, and if time permits, then we'll do the exact same thing, the entire thing, using YAML script. Now till now we are doing it using classic. Now the same thing will be done using YAML. Keep this in mind and make sure you practice, because this is very basic which I showed you right now. Eventually this will go at the extreme level, and then we'll have a Java application in which we'll integrate all the testing components, JUnit test, SonarQueue, Jacoco, all these testing components, will put it together with Java. Okay, so that's it for me. If anyone has any questions, please do let me know, or else we can wind up the call for today. And I do see there's a Kishore is facing some issue with service connection. If there's no question, we can, Kishore, if you can share your screen, we can just get you working.
Yeah, I'm sharing the screen.
Okay, let me stop the recording. If there's no question, guys, no question. Okay, perfect. So I'm stopping the presentation. Yeah, Kishore, you can share your screen. I'm stopping the recording also, guys.